In this video, we are going to continue with the organic chemistry. Now, under this video, we'll look at esters, and the first thing that we need to know about esters is esters are also known as the alkanoids. Now, if we look at esters, we are saying these are just a group of organic compounds that are widely found in nature. So, since they are widely found in nature, some of these esters can also be made. So, then from there, we can look at the two types of esters. So, we have the natural esters. So, the natural esters are those that are widely found in nature. Then the second one, we have what we call the synthetic esters. So these are just the man-made esters. Now let's look at some of the properties for esters. The esters, they consist of the functional group, and this functional group is where we have this carbon with the double bond of oxygen and another oxygen. Now this part where we have the double bond between carbon and oxygen, this is what we call a carbonyl group. So this part is also very important. Whenever you see a carbonyl group and the oxygen where we have this type of double bond, is an indication that we are dealing with the esters. Now, this functional group, this is also known as the ester linkage. So it's a linkage because it links the alcohol and the acidic party of that particular ester. Now, the other thing that we also may have want to know is we'll look at the formula. So the formula for esters is like this, where these two arrows represent the carbon chain of any length. So this can be maybe represent the alcohol party. Then also here we may have the representation of the acidic party, because later on we are going to find out that an ester can be formed by reacting an alcohol and an acid. Now, away from this, we can also look at some of the properties of esters. The first property that we can look at, we can say esters are colorless. Then the second one, esters are soluble in water. Then we also have another one which states that esters are highly volatile and highly inflammable. Okay, now from these properties, let's look at formation for those of we considered to be the synthetic esters. Let's look at how can we make these synthetic esters. So we'll look at the process that we call esterification. Now, esterification can be defined as a catalyzed reaction in which an alcohol reacts with carboxylic acid to form an ester and water. Now, there are also some conditions that we need to have in mind as long as we are dealing with esterification, and these conditions are: we need the catalyst, and the catalyst is concentrated sulfuric acid, and the temperature about 180 degrees Celsius. Now, in terms of the value about temperature, it's not that a strict number. So what you just have to know here is it depends with the textbook or maybe the information that we have. So the key point is you just have to know that apart from taking place in the presence of concentrated sulfuric acid, esterification also occurs when there, or meaning when it is heated or where there is heat. Now let's look at this process of esterification. So we first need to have the alkano. So the alkano is just an organic alcohol. Then this alkano is reacting with carboxylic acid. Then the condition, we said we need concentrated sulfuric acid. Then and the temperature, or we can say heat. Then from there, the product is, we are going to get the ester. We can also call esters alkyl alkanoids, plus we have to get also water. So let's take, for instance, we use the methanol as our alcohol, then plus ethanoic acid, okay. So now the first part that we look at is how do we name the ester that can be produced from the two given reactants. So in our case, we want to know the name of this ester that can be formed from methanol and ethanoic acid. So the first part that you need to begin with when naming an ester, first you start with the prefix from the alcohol part. So in our case, we need to get the prefix, which is meth. Meth indicates that there is only one carbon in that particular alcohol, so we get meth. Then after you get that prefix, you need to add YL so that it becomes an alkyl. So this is the part here. So we have methyl. Then from the acidic party, you need to get the name up to where we have the N. So we have methyl. Now after N, you add OAT. Remember we said that all esters ends in OAT. So this is the name of this ester, methyl ethanoate plus water. Now let's look at the structural formula. So for the structural formula for methanol is just this. So the functional group for this alcohol is this hydroxide plus reacting with ethanoic acid. So under ethanoic acid, we are going to have two carbons. So from the acidic party, we need to have this carbonyl group. Then we also have to look at what happens when these two reactants are reacting. So when the two reactants are reacting, the alcohol will lose a hydrogen atom and the carboxylic acid will lose its hydroxide. So the hydrogen from the alcohol party will combine with the hydroxide from the acidic party to form waters, because we said we have water under the product during the process of esterification. Then from there we can now connect the remaining party. So the remaining part here is just this. So we write our structure here. Then we have O. Then this bond will bond with the half or the remaining bond after we remove the hydroxide, giving us now the complete bond. Then we are followed by this carbon here, where there is this carbonyl plus this carbon. Then we have hydrogen here, also hydrogen here, plus we have H2O. So this is the structure of methyl ethanoate. Now, from there, the other thing that you need to look at the structure is this part here. This part here shows the alcohol part. Then the remaining party with the carbonyl group here, this is the acidic party or the acid part. Now, if we look at these two parts, in between the acidic and the alcohol party, there is this structure here. So this is what we said is considered to be an ester linkage. So why is it called a linkage? Because it is linking the two parties. It is like the part that is holding the alcohol and the acidic party of this particular ester. Now let's try another example. This time we'll use the butanol as our alcohol plus the propanoic acid. So feel free to give it a try. Then the conditions, we have the same condition, concentrated sulfuric acid. Then we also need a certain percentage of temperature or heat. Now let's first begin by naming the structure of this compound, which is an ester. So we said from the alcohol party we just get the prefix, which is but. Then we add YL, so this becomes the alkyl butyl. Then from the acidic party we just get up to N. Then we add with the butyl. Then after N we add OAT, so we have named this particular ester. So this is butyl propanoate plus C. Then we have water. Then let's look at this one as a structural formula. So for butanol has 4 carbons. Then the hydroxide, so plus. Now for propanol we have 3 carbons. Then here we have this carbonyl group. Now if you remember, we said from the alcohol party we get the hydrogen, then from the acidic party we get the hydroxide, then we connect the remaining party. Then we have this all carbonyl party here. So sometimes you may be given this structure and the question is like identify the linkage. So the linkage is just this here, and we said this linkage is known as ester linkage because it is linking the two parties. Now from this list ester linkage we can see that the formula for this linkage is just COO. So this is how we can first name the ester given the alcohol and the acidic party, and also how we can draw its structure. Then let's look at some ways of naming esters. So this time we'll look at how do we name an ester given the structure. So let's say, for example, we have this structure. So the person is name the following compound. So we have this compound here. Okay, so now the first step to consider when naming an ester like this one, first we are going to identify the alcohol party and the acidic party. Now, you can now remember that where there is this carbonyl group indicates that this part is the acid party. Then the remaining part here, this is our alcohol party. Now, after you are done identifying these two, the first we need to look at how many carbons are there in the alcohol party. So you can see that we only have one, and the prefix for one is just meth. Then you add YL, so this becomes methyl. After we are done with the alcohol party, we can look at the number of carbons that we have under the acidic party. So we can see that we have 1, 2, 3. So the prefix for 3 is prop. Now we add AN. The AN indicates that we only have these single bonds here. Then after we add the suffix, we can now add OATE. So this is how we can name a compound like this one. Now let's look at another example. Okay, so now we can let's now name this compound. So under this compound, we first have to identify the alcohol party. So the alcohol party is this one here. Then after the alcohol party, the remaining part indicates the acidic because is where we have this carbonyl group here. So this indicates the carboxylic acid. Now after we are done with the identity for these two parties, we'll begin with the alcohol. So from the alcohol, we can see that we only have 2 carbons here, and the prefix for 2 carbons is eth. Then we add YL so that it becomes ethyl. Then we move on to the carboxylic acid. We have 1, 2, 3, 4. So we have 4 carbons. So it's bute. Then we add AN or ATE. So this is the name of this structure. Now, since we have some ideas about the naming of these structures, let's look at one of the chemical property. We are looking at the hydrolysis now, away from the esterification. We look at the hydrolysis. Now, the hydrolysis is just the reverse of esterification. During esterification, we said if you add an alcohol with an acid, you get ester plus water. But under hydrolysis, you get an ester plus water. So this time you are going to get alcohol plus carboxylic acid. Then the conditions we need now dilute. So we need dilute sulfuric acid. During esterification, we wanted or we added concentrated sulfuric acid. Then also it has to be heated, so we apply the heat. Then let's say, for example, we use propyl. So propyl pentanoate plus water under the same conditions. So what alcohol and carboxylic acid can we form? So we can see that the first part here, the propyl, where there is YL, indicates the alcohol that was used to produce this same ester. So propyl will become, we remove YL, so we have propyl, then we add A NOL so that it becomes propanol plus the other party we remove OATE, so this becomes penta, then we add OIC so that it becomes pentanoic acid. So this is what we call hydrolysis, and as you can see, this is just the reversing of the esterification. So, and it can work for any ester. Let's say, for example, if you have methyl propanoate. So if you have methyl propanoate, if that undergoes the hydrolysis, the product is the methyl will go back to its alcohol part, which is methanol. Then propanoate will become as propanoic acid. So this is how we look at some of the esters. So that's it for this video. If you have some questions about esters, please feel free to write them in the comment section below. And for those that may be looking for online lessons, feel free to also write in the comment section below. Thanks for watching.